Hello and welcome. This is a quick tutorial on image resolution and color depth as part of our series on data representation. Um, so what are we going to be covering today? And we're going to be looking at what is image resolution and what is color depth. So first of all, I'll start with image resolution. This essentially means the size of an image, not in the number of kilobytes or the physical space it will take up in ones and noughts on the hard drive, but more in the dimensions of it. And so often it is represented as a height times a width, so 100 pixels times 500 pixels, or in the case of the diagram below, that would be 1 pixel by 1 pixel, moving up, and you can see how as it gets up to 100 pixels by 100 pixels, the image becomes less pixelated and clearer. And actually, you'll be familiar with your cameras measuring things in megapixels, or maybe sometime in the future gigapixels. Um, and that basically means a megapixel is 1,000,000 pixels, or 1,000 pixels by 1,000 pixels. So your screen that you're looking at right now is probably the resolution of about 1,000 and some number of pixels times about 700 and some number. And so roughly about just under a megapixel in size. And sometimes resolution is confused with dots per inch, or DPI. Dots per inch is the number of pixels that are represented on a physical medium such as printing or video quality, and it basically means the density of the pixels in the real world, and not resolution, which is the size of the actual image that you're trying to represent. So if you have a high DPI monitor, it would represent a high it could represent a high resolution image in a smaller space than a lower DPI monitor. And finally, we should look at color depth, and this is a little bit more complicated. Color depth is essentially the amount of bits that are used to store all the different colors in an image, and the number of colors is represented as 2 to the power of the number of bits that you've got to represent them. So for example, if you have 1 bit to represent it, 2 to the power 1 is 2, meaning that you can represent 2 colors. So 1 bit, that's black or white. And so just to come on here, so we've got 1 bit of color, as I said before, and that's can be either black or white in an image, and nothing in between, and that's called a monochrome image. And as you increase the number of bits, so 8 bits, you've got 2 to the power 8, meaning that there's 256 different colors. And I'll take an aside to just point that out. So if you've got 8 bits, or a byte of data, 1, 2, 3, 4, 5, 6, 7, and 8, the highest number that you can represent is all the ones. That's the biggest number. And the smallest number you can represent is all the zeros. 0, 0, 0, 0, 0, 0. And so that gives you a range between these numbers, and there's all the different combinations you can represent. That one there, the biggest number being 255, and the smallest number being 0. So between there and there, there's 256 different colors, and 256 equals 2 to the power 8. And you can do this with any number of bits in an image. And so you'll see here that 256 is kind of at what you would expect, although it does seem like a little not quite natural color. And so moving on, 16-bit high color is another common color definition, and also you've got 24-bit true color. And I should probably take a step back, and you'll notice that I've labeled these one indexed color and one direct color. So indexed color works using a color table, meaning that within the bitmap or image, there's a selection of colors that you can kind of pick your colors from. And so the colors are numbered, in this case 1 to 0 to 255, and each one has a given color in the color gamut to represent it. Whereas direct color is worked out by using a function of the amount of red, the amount of green, and the amount of blue. Now you may not be familiar with using red, green, and blue as your colors. If you're used to working in paint, then it'll be red, blue, and yellow as the prime colors. However, the prime colors of light are red, green, and blue, and they produce yellow, cyan, and magenta as the outcomes of mixing those colors. you may be more familiar when you're inside a program of changing the levels of these colors. And actually 24-bit true color allows 1 byte for red, 1 byte for green, and 1 byte for blue. And that's why within a byte of data you can go from 0 to 255. These values here change between 0 and 255. And so if you put all the color together, as in 255, 255, 255, you'll get the color white, because you're mixing it all. If you put red mixed in with green, so 255, 255, and 0, you'll get the color yellow, so on and so forth. And these are called direct colors because they use the color channels of red, green, and blue, or some similar prime colors. And this red, green, and blue, there's different ways of representing this. There's an arithmetic way where you choose the values between 0 and 1 as real numbers, as in fractional numbers. You can represent it as percentages, so this is for red, so that's 100, 0, 0. Or you can represent it using the 8-bit channel, so 255, or switch that into hexadecimal for F and F. So just covering what we've learned within this tutorial, we've looked at what is resolution and how that's different to dots per inch, and we said resolution was represented the size of the image, and what's color depth, and that's the number of different colors that can be used to represent the image.